Whoa, you made it. Here's video learning with Mr. Gregory. You're in Algebra 2 right now. This is so exciting, your very first educational video. We're hopping right into section 1.2 today. It is a super review section. You should know how to do everything in today's section without me even reminding you. But let's see. Today's title is called Evaluate and Simplify Expressions, which is basically math for can we use order of operations and can we combine like terms? And that's what the essential question is. How do I use order of operations and combine like terms to simplify expressions? Let's take a look at the first example. I need to evaluate this expression. I don't know if you know what an expression is, if you remember that term. It means this. It's a collection of math symbols, x's, numbers, and such, without an equal sign. There's no equal sign. When I see the word evaluate, that means I need to simplify it as much as I possibly can. So in this case, I have an x equals -3. Now you guys are pros by now, since you've been through Algebra 1 and geometry. You know that that means put the -3 in every single place I see the x. Keep in mind we're going to do this in parentheses. It helps us keep our work organized. It helps us realize what's really going on with the problem. So let me write the -3 instead of an x, and remember I'm doing it always in parentheses. Now hopefully at this point you've had enough math experience under your belt that you're not just going to barge right in and do -4 times -3 is 12. Oh, and then I have to square it, so that's 144. Some of you hopefully are shaking your heads right now and saying, that's poppycock, Mr. Gregory. I need to use order of operations. I need to follow PEMDAS. Hopefully that's you. Remember, PEMDAS is order of operations. Order of operations follows, a specific order, and PEMDAS is the acronym for it. So first I need to see, are there any parentheses that need to be resolved? Well, clearly I do have parentheses in this problem, here and here, but is there anything inside them that needs to be done? No, I just have -3s in there. There are no operations that need to be done. However, the e, exponent, I have some exponents, right? I have -3 squared. Now here's why it's important why I put that -3 in parentheses. -3 squared is different from -3 squared. It sounds the same when I say it, but it looks different when I write it. -3 in parentheses squared means -3 times itself twice, which is +9. That's the situation that I have here, so I'll write a 9 down here. If I had -3 not in parentheses squared, that actually means do 3 times 3 and put the negative in front. So my answer would be -9. I know that's a goofy way of doing it, but that's the way mathematicians work. That's the way mathematicians worked it out. So I have my 9, that was the result, and I'm going to do -4 times that. I'm just copying the rest of the problem down. Now, why did I just insert these times signs here? Hopefully you remember that when there is no operation in between two numbers, it's assumed to be multiplication. So that's why it's -4 times 9 and -6 times -3. And that's exactly what I need to do next. Because if you remember, with order of operations, multiply and divide are the next two steps, and you kind of do them all at once, moving from left to right. Well, in this case, I don't have any divide. It's just multiply. -4 times 9 is -36. -6 times -3 is +18. And then I have that +11 just kind of awkwardly hanging on at the end. Finally, I need to do addition and subtraction. And those also kind of go hand in hand. You just do them as they come, moving from left to right. In this case, I have only addition. So I'm going to do -36 plus 18, which is -18, and then -18 plus 11, which is -7. Final answer. Not too bad, right? You've had that a lot before. How about you try this next problem on your own? Go ahead and read it, pause your video player, take a shot at it. After you're done with it, we'll come back and I will do the problem with you. So pause your player now, do the problem. All right, hopefully you got the answer. We'll see if you got it right. This is another evaluate the expression ones, which means here's the expression and I need to simplify it. Clearly here we need to be plugging in some variables. We know what these variables are. I'm going to plug in a -2 everywhere I see an x. So let's do that real quick. -2 on top and 4 times -2 on the bottom. And then I need to plug in a 4 everywhere I see the y. So finishing out the top, plus 2 times 4, bottom just -4. Now, this is another problem where we have to follow order of operations. We have to follow PEMDAS. As with the last problem, there are no parentheses. Well, I mean, there are, but there's nothing to be done inside of those parentheses. Probably I should have put parentheses here too, since it was an x that I plugged in for. However, whenever you're working with fractions, there are kind of invisible parentheses around the numerator, the top of the fraction, and the denominator, the bottom of the fraction. Here's what I mean by that. You could put a second set of parentheses, I'll use brackets, around the top and the bottom. Basically, I need to do the top and the bottom separately. So parentheses sort of show up when you have fractions. Next step is exponents, none of those. Next step is multiplication. So we're good at math by now. Let's just kind of do that in our head. I know that on top, this 2 times 4 is going to be 8. I know that on the bottom, this 4 times -2 is going to be -8. Finally, I need to do the addition and subtraction. On top, I have -2 plus 8. That's +6. On the bottom, I have -8 minus 4, which is -12. Now, just a reminder, it's totally fine to have a fraction in your final answer. That'll happen from time to time. We just need to make sure we can reduce. In this case, I see that I can divide the top and the bottom by 6, so this fraction reduces to 1 over -2. And we're done. Perfect. Did you get it right? I hope so. Okay, here's a simplifying expression. It has a lot of variables involved, but unlike the last couple, I don't have w equals or x equals. It's just variables. This is the situation where, since I don't have anything to plug in, I have to be content simply to combine like terms. But if you're like me, I kind of enjoy combining like terms. It's like pretty easy. I make less mistakes doing these type of problems than like example 2 types of problems. There's just less numbers to worry about. What is a like term? We need the variable to be exactly the same to have a like term. So is w the same as x? No, obviously not. They're not like terms. Is w squared the same as w? Well, no, because this guy doesn't have a square. It's just w. So I'm only going to combine this w squared with the other w squared, which is here. And 10w squared plus 3w squared, I'm just going to add up the coefficients, which remember are the little numbers out front. That's 13w squared. Let's move on to the w. I'll double underline it just so I know it's a different term. This w combines with this w, and again, add the coefficients. -4 plus 18 is positive 14w. Finally, the x's. This -3x is going to add to this 8x to give me 5x. And that's it. That's all the like terms I have. I'm done. I don't have anything to plug in for the variables. I'm done. One last problem. In this problem, I have parentheses. Order of operations says I need to do what's inside the parentheses first, but let's look at this parenthesis. Does it have another x in it? No. Does it have another constant term or term without the variable? No. Does it have another x squared term? No. And there are these terms over here, but they're trapped in the parentheses right now. I can't do anything about those. They're like in jail over there. I have to free them. So we're going to free them by using distribution, which is another one of my favorite properties. Everybody loves distribution. It's easy. It's fun. I need to multiply 6 times everything in the parentheses. So 6 times x is 6x. 6 times -2 is -12, and 6 times 3x is positive 18x squared. Let's do the same for the other parentheses. Make sure that you're distributing in the -2, not just +2. -2 times x squared is -2x squared, and -2 times 6x is -12x. Okay, so now all we have to do is combine the like terms. I notice that I have an x term here, so 6x minus 12x is -6x. I have a constant term here. Remember, that's the one without the variable, and there are no other ones, so that just shows up in my final answer. And finally, I have these 2x squared terms. 18x squared minus 2x squared is 16x squared. Final answer, because I cannot combine any more like terms. That was the lesson. Was it easy for you? Hopefully. It was a review of stuff that you've done every single year pretty much. Just a reminder, when you tackle problems, you have to follow a specific order, and that order is PEMDAS. Also, don't forget, when you're combining like terms, y's don't combine with x's, and x squares don't combine with x's. You can only combine like terms if they have exactly the same variables.